Remember that when writing the prime factorization of a number, you're writing the number as a product of its prime factors. And there's only one unique prime factorization for every integer greater than 1. In the previous video, we discussed how to use the factor tree to write the prime factorization of a number. In this video, we'll focus on how to use the ladder method to write the prime factorization of the number. But either method you use, whether it be the factor tree or the ladder diagram, if done correctly, you'll get the same answer in the end. Remember that a prime number has exactly two factors. Those two factors are 1 and the number itself. A composite number means that the number has more than two factors. So in example number 1, we're going to look at the number 36. Now, to use a ladder method, you first write the number and draw an L. You could say an L for ladder. Then you pull out a prime factor. Now, this factor must be prime for the ladder method to work. That is what is unique about the ladder method. Now 36 is even, so I know that 2 is a factor of 36. So I'm going to pull a 2 out. Then I think to myself, 2 times what is 36? Well, that would be 18. Okay. Now 18 is composite. I can break that down further. It's even, so I know it's divisible by 2. So I make an additional ladder, pull out another 2. 2 times what is 18? Well, that would be 9. Okay, now does 9 have any prime factors? It does, right? 3 is a prime factor of 9. So make an additional ladder, pull out a 3. 3 times what is 9? Well, that would be 3. Finally, does 3 have any prime factors? It does, right? 3 is a prime factor of 3. So I make an additional ladder, pull out a 3. 3 times what is 3? Well, that would be 1. Now, once you have 1, you know you're done making ladders. Okay, so I'm finished with the ladder method. So I make additional ladders until I get a 1. Now, the prime factors of 36 are these numbers on the left. These numbers right there multiplied together are the prime factorization of 36. Okay, so I have 2 times 2 times 3 times 3. Well, I have two 2's being multiplied together, so that's 2 squared, times 3, 2 3's, 3 squared. And 2 squared times 3 squared, well, that would give me 36. So that is the prime factorization of 36. Now let me show you what would happen if I have 36 and I'm using the ladder method and I don't pull out a prime factor. Let's say I pull out a 4, which is a factor of 36, it's just not prime. Well, 4 times what is 36? That would be 9. I pull out a 3. 3 times 3 is 9. 3 times 1 is 3. Okay, so now if I look down the side here for prime factors, well, those are not all prime, right? 3 and 3 are prime, but 4 is not prime. So that's why I must pull out a prime factor if I'm using the ladder method, so that what I end up with is indeed all the prime factors. So that's example number 1. Example number 2, let's write the prime factorization of 63. Okay, so write 63 and draw an L for ladder. Okay, so what is a prime factor of 63? Well, first think about 2. Is 2 a factor of 63? No, it's not, right? Because 63 is odd. What about 3? Is 3 a factor? Well, let's add up these digits. 6 plus 3, that's 9. Is 9 divisible by 3? Yes, it is. So that means this number, 63, is divisible by 3. So I can pull out a 3. Well, 3 times what is 63? Well, I don't really have that one memorized. So what can I do? Well, I can do the inverse of multiplication, right? I can do 63 divided by 3, and that would give me 21. Okay? Now, 21, can I pull out a prime factor for 21? Yes, I can, right? 21 is divisible by 3, so I can pull out a factor of 3. 3 times what is 21? That would be 7. And 7 is a prime factor of 7, so 7 times 1 is 7. I have a 1. I know that I'm finished. So these are my prime factors right here. 3, 3, and 7. So 63 is the same as 3 times 3 times 7. I can write these 3's using exponents, right? 3 squared times 7. That's the prime factorization of 63. Okay, I want you to try these two on your own. We'll call this example number 3. write the prime factorization of 64. And example number 4, I want you to write the prime factorization of 66. All right, try those two on your own.